And now we're happy to address any questions you have about data mining and predictive analytics. You can think of this as the free consulting segment of our webinar, open access to the modeling agency's advanced analytic gurus, senior consultants Keith McCormick and Scott Terry. However, stepping in for Keith for the Q&A, and this is to add a lot of fun and even a little confusion with another Scott, is Scott Glendaniel. Scott's another highly seasoned senior consultant and trainer with a wealth of direct commercial experience in organizational analytic implementation and a long-standing relationship with the modeling agency, actually starting out as a client in 1994. My gosh, Scott, we are getting old. So thanks so much for stepping in on short notice, Scott. Each question you submit will receive multiple perspectives. We do have great questions coming in now, a few, but there's certainly room for a few more for the next 15 minutes here that we have to share with you. So just enter your questions into the text field of the webinar panel, and I'll be pleased to read them aloud for Scott, or myself to respond. So let's start with a great question from Bobby. And Bobby, given the strategic context that we presented, we're going to assume that you've already taken the steps to kind of get to that chapter 5 in the middle of the book here, because you're asking a question about a tool. So we'll assume you've done the proper strategic upfront work, and the question is, what statistical tools do you prefer or find yourselves using frequently when exploring and then modeling? And I might lead a little bit to say that sometimes there are statistical tools that you'll use for either one, statistical and machine learning tools or algorithms need not be competitive, that they are certainly complementary and fitting for different kinds of situations. That's the kind of answer we as consultants always like to say, right? It depends, but then we certainly have the experience on the situations as to where it makes sense to apply this or that. So let's start with Scott Glendaniel, and let me make sure we've got your audio, Scott. And what would you say to Bobby for what statistical tools do you prefer or find yourselves using frequently when exploring and then modeling?
Sure. In answer to Bobby's question, 2 points I would make. The first one is you're going to have to adapt which algorithm you're going to use based on the problem that you're facing. That being said, for the upfront work, for data prep, for the exploratory data analysis, the initial phases, I tend to use classification and regression trees quite a bit, mostly because they're very easy to interpret and they're impervious to a lot of statistical issues that beginners tend to make. For a final algorithm, what seems to be, at least in the industry literature and what I'm experiencing, what seems to be taking most of the Kaggle competitions for the past 5 years or so, is stochastic gradient boosting, also known as TreeNet, which is basically a bunch of little decision trees put together where each tree learns from the tree before. So I don't want to give too nebulous an answer, so I answer it specifically, but again, it depends on what you're trying to do and what problem you're facing.
Sure. I even preface it that way, that's often our favorite answer, but at the same time, you're right. We want to offer advice where we can. And as I take this over to Scott Terry, might even preface this a little bit with the tools and our methods. And I had somebody drop in my office here and just knock me completely off track. So I'm going to just send the question over to you. If it pops back into mine, I'll add it on at the end, Scott. But again, it's about the tools and what do you find frequently using when you explore and then model.
Wow. Okay. Can you hear me first? I had put myself on mute while Scott the Grader was talking. Can you hear me okay?
Sure. Yep. No,
okay, super. Well, it's an excellent question. We get asked it a whole lot. I'm assuming something a little bit different. When I'm thinking about tools, I'm thinking about software environments. In terms of software environments, there's 2 commercial leaders and there's 2 open source leaders. In terms of the commercial leaders, which are all of these tools that we're talking about are good for both applications, for both exploratories as well as final model development, and you can even let the models live in these environments. But the two leading open source tools are R. Sound like I'm barking, don't I? Anyway, R and Python, and both of them are excellent Both of them are excellent. Both of them, probably the biggest difference between the two is if you have other stuff that you'd like to do. For example, you know, put your final model in production, maybe even attach it to a website that you developed in R itself. R is more inclusive than Python is more inclusive than R. R is probably got a few more algorithms and is a little bit more analytically focused, but both of those are great open source tools. The two leaders in the commercial side market are SPSS and SAS. They're like, you know, 30, 40 years ago when the saying used to be, you can't go wrong with Big Blue. You can't go wrong with any of these tools. SAS and SPSS are more mature tools, and I would probably venture to say, and say it with some confidence, that SPSS and SAS are more mature tools. That they're more industrial strength too. If you've got some really huge problems that you're dealing with. But really, after saying all that, I'm reminded of my good friend Tony Rathburn when he would get asked this question. He used to say, "It's the tool you're working with right now."
Yeah, exactly. And you know what? You reminded me of my brain collapse when I was transitioning from Scott over to you. Was to quote Tony. You know, he said, "As much as we are vendor neutral, and you know, we certainly want to mention our experience with different tools. We don't want to endorse any or disparage any." But at the same time, he would say, we do have a favorite tool, and that's the one you already have in-house, or the tools you have already in-house. And that comes into that broader assessment that we often talk about. And it's not just about the tools you have in-house. It's about the overall environment. It's about the broader situation. It's about the experience you have in-house. It's about what you want to achieve with analytics, what methods are going to be used the most, what kind of deployment requirements do you have? Is it going to be, you know, live scoring? Is it going to, you know, we need to know all of those things to the point where in our assessments, when we do a comprehensive assessment, we don't recommend investing in commercial software for your prototype, for your first initial model. There's a lot to learn about software. And as you noted, Scott, the open source software is so highly capable that you can use that for your first pass. And once we collect a lot of the context that we need to make a commercial software investment or justify it, then we have a lot more targeted information so that we don't overpurchase or underpurchase. We get a right-sized, very targeted commitment to the right tool for our situation, our team, our environment, all the rest. It's incredible how many organizations squander funding by purchasing software by the last vendor to have presented or the best one to have presented. So that's not a recommendation that we make, and we say, you know, refrain for a while. Getting the best R squared or artificial metrics isn't the most important thing on the first run. So great advice all around. Scott, oh boy, just when I was saying Scott and Scott, let's not make it more confusing, but another Scott asks, do you worry a lot about testing the assumptions of techniques, for example, assumptions of regression around normality of errors, or do you depend more on measuring model fit of testing and validation of the data set? So a much more tactical, kind of technical question. Let's start this time with Scott Terry.
What a fantastic question. I really love this question because it shows that somebody's got a little experience, plus in addition to liking his name, and has probably been down the road a little bit. I have a bias. You know, when analytics is an art form as much as it is a science, and my bias is I have a statistical a non-statistical test that I apply to every model I build, and it's called the sniff test, and that is, does it make sense? So that leans me towards, okay, all the metrics that you're looking at are fine and dandy. I look at them like instrumentation on a dashboard of a car you're driving. but you know, the thing is, I'm driving the car, and if the oil light is off, blinks on and off a couple of times, the important thing is to get to the destination. So in spite of all the model statistics, you're never going to find a model, I think is a fair statement to make, that is going to pass every model statistic that's generated. I think software providers a lot of times generate 10 times more model statistics than are required just because they want it to look cool. But I look at the model statistics, they're very important, but the most important thing to me is does it train and validate well, and does it pass the sniff test?
Great advice. Thank you, Scott. Scott Clendaniel, would you like to extend? And if so, just let me know if you'd like me to reread the question.
Sure. What I have found over doing this for a very long time and assuming that I was always wrong, I had always taken an approach of using 7 or 8 algorithms against a single problem at a single time. And I have found that the performance among algorithms and the underlying statistical tests, or what I should say, the underlying statistical assumptions that are made, don't help a whole lot. And what I mean by that is, if you look in the social sciences, you can't swing a dead textbook without hitting logistic regression and having everyone tell you that that is the solution to any binary outcome. I have found that absolutely not to be true. Most of the assumptions underpinning most of regression involves things on normal distributions of data, which almost never happens in the type of real-world problems that I face. So I tend to ignore the underlying statistical assumptions because I find that they don't have a whole lot of bearing. I am much more focused on what the data says, a robust testing approach. I tend to focus a lot on cross-validation so that I don't end up with overfitting problems. It's all, for me, about the problem and the data as opposed to the underlying statistical assumptions.
Great complementary perspectives. I thank you, Scott and Scott, for the great question. And moving on to what will make the last question, and oftentimes in the Q&A, some initial questions will lead to a cascade, and then we can't get to them all. In this case, we did have a smaller group, maybe somewhat more of a shy group, so looks like we'll be on time nonetheless. With 5 minutes remaining, we'll take the last question from Nita, who asks, in software, could standard models for predictive analytics be applied? If yes, which ones? So I think that leaves a little bit open for interpretation, but I'm thinking that this may mean, you know, kind of packaged models, I'm going to guess. And Scott, if you'd like to, if your interpretation is different, by all means, answer it in a different direction. But I'm thinking, you know, in software, could standard models for predictive analytics be applied? I would say normally no, but in certain special situations where you have pretty much the same dimensions that are collected, the same overall environment, there has to be a lot strategically upstream that has to be the same in order for that to apply. And, you know, Scott Clendaniel, you've worked so long with financial data, and with all the attitudinal data that you work with, Scott Terry, you've probably seen instances where you learn which specific attributes apply to certain situations where, okay, you can start to build a factory perhaps that includes the same kind of data transformation and preparation. Having said that, outside of that narrow condition, I would say it's very dangerous for a lot of the reasons that Scott Terry had expressed earlier in the presentation, that a lot of the preparation that you do is highly situational and involves a lot of the experience of your subject matter experts and the ways in which you're going to treat the data and what ranges even make sense. And sometimes that helps you to determine what truly are errors and outliers versus points that could be of the greatest interest. So let me start with Scott Terry this time. I hope that's who I started with last time. And the question, in software, could standard models for predictive analytics be applied? And if yes, which ones? And if you have a different interpretation of the question, feel free to take it where you'd like. Scott Terry.
Thank you for the question, Nita. That is how I heard it. I've heard this kind of question before, and I would say, bottom line is no. you know, it's a good thought. It's a good thought. But if you think about any entity that you're modeling, just take 2 banks, for example. First of all, even though both banks have, you know, they have checking accounts and savings accounts, their product mixes are different. Their terms are different. Their locations are different. Their consumer mix, because of their locations, are different. And the way that they collect data and the exact data that they collect can vary quite a bit too. So from a high level, you may be a financial expert, and to Eric's point, you can narrow down variables that are usually predictive. You know, they generally be, or the recency, frequency, and monetary types of variables in terms of a high level. But from that point, you know, every application is unique. It's not a good idea to try to, you know, to take one model that you develop in one environment and try to apply it to another. But it is a good idea to take the experience and the subject matter experience that you've learned about an environment from, you know, one business in one industry to another business in the same industry.
Almost scared to think how often we find those with the mindset that you can have a tool, an automated tool, just take the data at one end and come out with your results in the other for implementation. And you can come up with some pretty impressive model accuracy results, but at the end of the day, where's it going to, you know, it's going to be so inaccurate, and so many don't understand it. You can't blame them. I mean, there's so many BI projects where you get the tool, you apply the data, you come up with an answer, and you apply it. But in predictive analytics, it couldn't be more dangerous. You know, and you certainly did a great job of driving that home in your presentation. So Scott Clendaniel, as they say, you get the last word. How'd you like to sum up around software and automation?
I would like to quote that famous predictive analytics expert robot from Lost in Space, Danger Will Robinson. Any time that anyone is coming to you and saying, oh, we've got a pre-canned solution, I would be very concerned. The only time I would apply one is if I don't have resources, time, or experience to be able to do it myself, and I have a ridiculously rigorous testing program. But I can tell you that I've worked in banking since shortly before the earth cooled, 1986, and I would say that, for example, the FICO credit scores, every bank that I've ever been at that has tried to create their own score has outperformed FICO. Not because FICO is a bad score, not because it's a bad approach. It's because the customization of their own data for their own problems is always going to outperform an industry-wide or consortium approach. End of sermon.
Okay. That's great, and I have to laugh out loud also, because every time you and I lament about how long we've known each other and how old we are, I'm sure Scott Terry has to roll his eyes. Great, Scott Terry, but I know it's all relative, but nonetheless.
I still have my first abacus. What are you talking about?
Yeah, exactly. What? That's not what we all do analytics with? Well, at 31 minutes past the hour, we'd better draw this event to a close. I'd certainly like to thank our attendees today for your sustained interest and your active participation, as well as Scott and Keith for your great presentation segments, and certainly Scott and Scott for the highly informative Q&A contributions. We'll follow up with an email shortly with some resources and suggestions that will hopefully be useful to you. From there, we hope you've offered permission for us to stay in touch through the Modeling Agency's newsletter, and that you'll consider joining us at a public training event soon. So make sure to go to the website to check out the schedule and details for next month's courses in Washington, D.C., or the upcoming online productions in November and December. Now, if you don't have a training budget, or your schedule just doesn't fit, but would like the guidance of a seasoned mentor like Scott, or Keith, you might be interested in the Modeling Agency's Escort on Call program. Escort on Call is essentially a retainer account that provides remote open access to a TMA senior consultant. Simply open up an Escort on Call account, and you've instantly added a wealth of experience and capability to your existing bench without expanding payroll, administrating complicated contracts, or taking elevated risk on larger commitments. We'll get you the answers you want, guide you through it, whether it's tactically or strategically, show you how it's done, implement any data mining tasks you may wish to delegate, and then remain on call until the next time you need us. And meanwhile, When we're not actively working, you're not paying a dime. So a link to the Escort on Call description page will be among the resources included in the follow-up email. On behalf of myself, Scott, and Keith, thank you again for attending Predictive Analytics Failure to Launch. Have a very pleasant afternoon and evening, and this brings the webinar broadcast to a close.